Today we are going to demonstrate how to filter your samples. This is something you should do prior to running your samples on an analyzer or sorter. The reason for doing this is you're going to remove any kind of aggregate or large particles so you do not clog either the analyzer sample injection tube or sample line or the sample tubing of the sorter. We are going to start by demonstrating how to filter using a Falcon 5 milliliter polystyrene tube with a cell strainer cap from Fisher Scientific. These are reference number 352235 or Fisher part number 0877123. This is what the tube looks like when it is removed from its packaging. There is a 5 milliliter polystyrene tube with a 35 micrometer cell strainer cap. I am now going to demonstrate how to filter our samples using a transfer pipette. With the transfer pipette package open, we are going to take our sample and vortex it so all the cells are in suspension. We are going to place the pipette into the tube and aspirate all the sample. And then we are going to run the sample through the strainer cap. Push a tiny amount of sample onto the filter. I find it works best if you wet the filter first. Then pull that small amount back into the pipette and then push the entire sample through the filter. Once all your samples pushed through, your cells have now been filtered. Anything in the tube is less than 35 micrometers. The typical orifice of sample injection tube or sample tubing is 100 micrometers or more. So there should be nothing in the tube that should clog the cytometer if you filter your samples right before you put them on. Another alternative for filtering, since the 5 milliliter Falcon tube with the cell strainer cap are fairly expensive, is you can order the mesh itself. This can be ordered from Genesee Scientific. You can order a 30 micrometer mesh. The part number is 57-105. It's a cheaper alternative to the Falcon tubes, especially when people are trying to save money. The mesh comes in a roll, which you will be able to cut a piece to size for whatever type of tube you might be filtering through. I have already cut a piece to size, though it's a little bigger so that you can see in the video. We are going to place that on a standard 5 milliliter tube, and we are going to filter our samples. We are going to take our sample again and vortex it to get all the cells that settled to go back into suspension. We are then going to pipette our samples out of the tube and place the pipette onto the filter mesh and push the sample through. We have now filtered our samples through the mesh, so you can confidently place the tube on the cytometer because you know everything in the tube is less than 30 micrometers. Once again, using the mesh filter works just as well as the strainer cap tubes and is a cheaper alternative. Those were two alternative ways to filter your samples. Ideally, you want to filter your samples right before you put them on the cytometer. This way you can be assured to have removed the clumps and the aggregates. Remember, if you are using clumpy or sticky samples and filter your samples prior to your run, you may need to filter them again, especially in longer runs. If your samples were clumpy and sticky before you filter them, they are still clumpy and sticky after you filtered them and can reaggregate or form clots. Another helpful tip is the unaided human eye can only typically resolve objects as small as 100 micrometers. So if you see an object floating in your sample tube, you will need to filter them, as most sample tubes and sample injection tubes are only around 125 micrometers. Before I finish this video, I wanted to just pull up the two different filters that I used to demonstrate in this video. These are just two examples of the filters that you can buy. Though these two products work well for our lab, you may find that you like a product from a different company. Our goal for this video is to demonstrate that filtering is important and how to do it. I hope you find the following video to be helpful. Please like and subscribe to the ISAC YouTube page and follow ISAC on all their social media platforms. Thank you again for watching.